You guys hear me? Cool. All right. Hey, thanks everyone for coming. Like you said, my name is Nick. I'm from Teller. Um, Gave you guys a nice technical subject so you guys could tweet it out for me. Sound nice and esoteric. Um, right. All right. So to kind of get into it, first I'm going to describe to you guys what oracles are. I think most of you guys already know this, but I've run into a few people here that didn't know it. So smart contracts, they can't actually read external data. So whether it's another blockchain, whether it's just a plain API, if you want a price feed, you want to know what the weather is, anything off chain, smart contracts can't know this. The main reason is like smart contracts, if I run a smart contract function, you should be able to run the exact same function tomorrow, a year later, and get the exact same answer. Obviously, if you're querying some sort of API, you can't do that because they return different things. So you need somebody to basically put it in as an input. The person that is placing it as the input, that's an oracle. So you can have the super easy oracle. So I could just say, hey, you can be my oracle here. That would be great, except it's a fully centralized oracle. He could lie and he could change it. You could use a multi-sig. That's kind of what a lot of people do in the space, where we'll just pick two of you, and now you guys are two out of the three people can be the oracle. A lot of times, some people will say like decentralized exchanges can also be an oracle. So if you're looking for a price feed, could just be something like that. But basically, any method for coming up with consensus can be your oracle. How do you decide on what to input into that contract? Okay, so what are oracles used for? The big thing most of you guys know, most of you guys have probably heard of Chainlink in terms of price feeds. So price feeds are the big use case right now on DeFi. So if you have a stable coin and it's backed by ETH, you need to know how much ETH US dollar is to make sure the whole thing's collateralized. Lots of other price feeds, derivatives contracts. So if you're saying doing a futures or options contract, well, how do you get your settlement price? Other ones that people are now starting to experiment with, so bridges. So if you're building a bridge to Bitcoin, you need an oracle. You can pass block headers back and forth. You can also do cross-chain AMMs. So Thorchain, if you have a liquidity pool on two different chains and you want to pass them back and forth, you use oracles. Other things, prediction markets, insurance. I'm sure you guys know most of those. Okay, and I loved that Preston, if you guys saw, he included this in his slides earlier. So this is the scalability trilemma, the blockchain trilemma. Basically, there's always this trade-off between being decentralized, secure, and fast. And most people seem to get this whenever we talk about L1s. So if somebody came to you and was like, oh, I'm doing a new L1 and it does 100,000 transactions per second, you guys would be like, that's probably bullshit, man. Like you just wouldn't believe them because you're like, like we all have sort of realized like this holds for L1s. Like, unless you have some really big technological breakthrough, it's hard to do that in a decentralized way. Well, this actually holds for oracles too. So if you want to have decentralized oracles, you want to have fast oracles or secure oracles, it's a trade-off. And it's something that we just need to sort of realize and accept in the space, especially in kind of the DeFi space. So what we're going to talk about today is mainly whenever it comes down to what is subjectivity and finality. And they're sort of two sides of the same coin. It's basically like, how do you know what you're putting on is actually what you're putting on? So the first question to kind of get into, like whenever we're trying to create, say, a decentralized oracle, or we're trying to use an oracle in the space, is like, well, how do you make something decentralized at all? So bringing it back to like the L1 layer, there's basically two components to it. So first, you need anybody who can participate. So that's like first check of something being decentralized. If you have a whitelist group of nodes that are your only validators on your chain, you guys would all just be like, well, that's cool, but it's been done and it's not decentralized. So anybody has to be able to participate, and the other thing is anyone has to be able to validate it. So those are two key components of being decentralized. So for an oracle, when we think about building a decentralized oracle, it's, well, you need a system that, okay, anybody can sort of go on there and participate in being the oracle, and then anybody has a way to check it or dispute it. So Hopefully nothing too radical here so far. And the big challenge that you realize with oracles is that there's kind of these layers of finality. So to use an example of layers of finality, we'll think about a really easy one, like what is the Bitcoin price? So we're on Ethereum and we want to put the Bitcoin price on chain. Okay, well, what is the Bitcoin price? You know, there's a really big difference between what's the Bitcoin price on Coinbase, what's the Bitcoin price on Binance, what's the Bitcoin price on any of these exchanges, maybe on some sort of DEX. So first you need the value to be generated. Then you need, you know, say the APIs have to generate it. That might take a few seconds. Market trades have to happen. Then you need the value to be placed on chain. So if you guys saw Preston's talk this morning, he was talking about finality on ETH 2.0. Finality on ETH 1.0 is sort of, it takes a while. Same with Bitcoin. You know, if we're talking about the Bitcoin price, finality, you know, if you make a deposit on Coinbase, well, they're actually going to make you wait an hour before you go and spend that because the chain might reorg. It just happens. So you have to wait for the value to be placed on chain. And then similar to the value is verified. So if your Oracle provider places it on chain, you should be able to say, hey, he lied about putting it on chain. And that would be the value verified. And then finally, the value is usable. So as you can see, there's a lot of sort of challenges in making these really fast Oracle updates. So whenever you're talking about building really, really fast bridges or really fast DeFi protocols, there's a lot of things you sort of gotta pay attention to, and this is what I'm gonna go over. So the first piece, value generation. So this is for, there's kind of two pieces here, mainly for bridges and for price feeds. For price feeds, it's really an easy one. You just have to wait for the API to update. But this gets into like, well, should you just use a spot price on an exchange? The answer is probably no. Don't do that in your DeFi apps, mainly because if you know spot prices, they can sort of be thrown. So if you wanted to, that's why most people shy away from using Uniswap as like their oracle. It's because there's kind of a price to throw Uniswap in any given instant. So you can use Uniswap TWAPs. So TWAP is time-weighted average, so you just average it over the last half hour. But this means you sort of got to wait for things to update. But the big one for bridges and oracles is you have to wait for some of these chains to be finalized. I threw this website up here, crypto51.app. This is actually the cost to 51% attack different chains. And most people, like if you actually think like, well, Bitcoin's, I don't know what Bitcoin's market cap is, but you're like, oh, it must be crazy expensive to 51% attack Bitcoin. It's not. It's about $1.5 million, and you can 51% attack Bitcoin for an hour. So if you just wanted to stall out Bitcoin for a whole hour or reorg it, it's, you know, $1.5 million. It's a lot of money. I don't have $1.5 million, but if you have a DeFi protocol that's reliant on that chain being finalized, or a bridge where you're locking money on Bitcoin and then spending it on some other chain, it's not that much money. So that's kind of the first piece in making fast bridges. It's probably really, really hard. Okay. Next piece, so chain inclusion. This is a big one for oracles because there's kind of multiple ways to attack oracles. You can, the easiest way to attack an oracle, or the one that most people would think about is like, oh, I'll just be able to place a value on chain that's bad. So I'll say that, you know, the Bitcoin price is actually $10 million and I'll run away with everyone's money in a DeFi app. That is one form of an oracle attack, but the harder one for us oracle providers to stop is actually like if people just censor the chain from us. So like getting included on chain isn't really a guarantee. So, you know, similar to how Bitcoin cost $1.5 million to 51% attack, you could mine every block on Ethereum for about the same price. And that wouldn't necessarily mean that you're doing a 51% attack that's going to lead to some sort of reorg. You could do something where you actually just don't allow any calls to the Teller Oracle or to the Chainlink Oracle or to any of these oracles. And now what you're doing is you essentially just censored any price updates from getting into your DeFi app. And that's really, really dangerous because let's say you're relying on the price updates, so then you can go liquidate people. This can be a big problem, um, and it doesn't cost that much to do. So that's one piece of chain inclusion. Another piece to chain inclusion that we work on really hard at Teller is the gas price. So how many of you remember Black Thursday? It happened last year. So if you remember, basically what was it? All crypto prices and the entire book just fell by like 50% in one day. It was really, really awful time to be around. But what happened is all of the oracles in the space like froze because the gas price, it was like the first time like gas price for a while was like, it was over 500 GWay and just stayed there for a long time. And all the oracle providers were like, man, I don't really want to pay that gas. Because if you had a centralized oracle, like let's say we were just relying on one guy to do it, how, why does he need to update it? Like, what does he get out of it? Like, he's just, he submitted the transaction, he's waiting for it to mine, he doesn't care. You as a user want it to update, but you have to make sure that you have a way to sort of do that really, really fast, because sometimes gas can get high and sometimes gas can stay high. So making sure that you have a way to get your oracle information on chain even whenever gas goes up is very important. All right, next piece, verifying oracle data. So verifying oracle data is, it has to do with kind of what is the subjectivity of data. I was just talking to somebody about it today. Verifying like a price feed is usually really easy. Like in the example I gave earlier, if somebody said that the price of Bitcoin was $10 million, that's probably easy to verify that it's wrong, and you can probably go slash the person or dispute them and say that they lied. But other ones can be harder. So I think the example he used was that did Houston win the World Series? Well, yes, and then no later. Or the example that more of you might be familiar with, like who won the presidential election. If you want to close that prediction market on election night, it might not close on election night, so you might have to sort of wait, and it might actually be hard to verify, and you might have to wait a really, really long time to verify it. So making sure that your protocol can sort of handle that is really important. So whenever you're structuring your DeFi protocol or any sort of protocol that relies on oracle data, making sure that it's easy to verify and that you sort of know, okay, what are the cases that can happen in when a dispute comes up? Because we've had some, and we had some people. I think we had an issue with Teller where they were looking for like they were requesting the BNB price of 0x on Binance. It was like it was BNB/0x, and it was on the Binance API. And what happened was Binance delisted that pair, but their API returned the last price of that pair. So it just kept returning the exact same price, even though BNB moved prices. And it led to like a bunch of disputes on our system that we eventually just had to, we resolved like just by voting them all sort of null, because somebody was just trying to break the system. But making sure that you sort of lay out, well, okay, what happens if all of the APIs that we're requesting go down? This can be tough. So, all right, how am I doing with time? Okay. So yeah, this is just kind of summing it up. So whenever you have all these different layers of finality, you just want to make sure that you're allowing more time for your app to sort of take hold. So if you're running a bridge, allow more time. This is one thing that we've been very critical of a lot of bridge design. So if you guys saw the wormhole hack recently, that actually had nothing to do with the oracles they were using, but people had pointed out for a long time, like wormhole it was a Solana bridge, and there was actually just a bug in their contracts that allowed people to drain the funds. But if you have these really fast bridges, what could happen is if you have a reorg on Ethereum, then you could have potentially spent all of the money on Solana and essentially done a double spend, which you don't want. So if there's more value in your system, if you have weird data that's harder to verify, if you have more subjective data like the presidential election, just give it more time, guys. Like we're up here trying to push for people to slow down DeFi, slow down some of these things. That way, it just makes more sense and it's more secure. Just kind of solutions, I guess, that you guys can plug in. Just make sure that you don't expect fast oracles. If somebody, similar to how if somebody comes up to you and says, our L1 can do 100,000 transactions, if they say like, you can have an oracle that's instantly final, just don't believe it, don't use it. Use something that makes sense. And this is, so I'll just tell you guys how Teller works, the quick pitch before I run out of time. We have a simple system where anybody can come. You guys can all go be a reporter on the Teller system. So what you do is you stake some TRB, which is our token, lock it into a smart contract, and then you can report data. So if somebody will come on and they'll say, hey, I'll pay you $10 if you throw the price of Bitcoin on chain, you put the price of Bitcoin on chain, you're good, you get the $10. If you lied about it, anybody out there can say he lied about it, and you can potentially get slashed from a vote, and you would lose your stake. So it's a nice, simple crypto economic system. We're live now on Ethereum, Polygon, Harmony. Yeah, shout out to you guys back there. And then we're going over on Algorand as well. So it's we're getting on a lot of chains, and yeah, hopefully you guys like the model, but happy to kind of answer any questions. And yeah, thanks for listening. All right, any questions? I don't know if I'm getting kicked off. Yeah. Yeah, so you just request the data. So like it's not like a job type thing. Anybody can sort of fulfill the request, if that makes sense. So it's a little bit different because there's not like anything signed that says they have to do this. It's just you incentivize with them with, we have what are called tips. So you would like tip them for this data. You can set it up as like a recurring thing to say like, hey, I'll tip you, $10 every hour to make sure that this price feed gets updated. But then anybody can sort of fulfill that request. So, yeah. So how do we handle disputes? Yeah, so it goes to a 2-day long vote. Right now it's split between, so you have token holders, then the reporters are also, they have a fraction of the vote, and then the users as well. So if you're one of the people who's tipping the contract, it's split between the users and the reporters get 25% each. So no, anybody can dispute. So you just pay a little bit of a fee to kind of spam prevent it. But the thing to note is like for a user, so like let's say you wanted the Bitcoin price in your contract, you wouldn't wait for the dispute to go through. What would happen is like if he got disputed, somebody else would just put the data on chain again. So like you would get it instantly. You don't have to like wait. You probably could care less. So all right. And then anything else? No? Hey, thanks everyone for listening.